what if we could power our entire world with just sunlight? I mean, really think about that. Today, we're going to dive into the amazing world of solar energy, from a single particle of light all the way to the tech that might just shape our entire future.
So, let's just get right to the big one, the question that's on everyone's mind. Can the sun, our very own star, really take care of all our energy needs? It's a huge question, and the journey to the answer is pretty fascinating.
But hang on, before we get into the how, we got to talk about the why. Why is everyone so focused on solar right now? Well, it all goes back to the energy crisis we're facing and the massive opportunity that our sun represents.
Look, our hunger for energy is just exploding. But the way we've been feeding it, with fossil fuels, comes at a really steep price. We're talking about greenhouse gases, pollution, and a climate that's changing way too fast. It's pretty clear this just isn't sustainable.
And this is where our hero steps onto the stage. Solar energy. It's hands down the most plentiful and cleanest source of power we've got. It's literally a nonstop river of pure energy, delivered right to our planet every single day, completely free of charge.
Okay, so how in the world do we actually turn a sunbeam into electricity? Let's follow the journey, starting with a single ray of light and ending with you flicking on a switch in your home.
It all kicks off with something super tiny, a particle of light called a photon. You've got to picture this. Trillions upon trillions of these little energy packets are making the long journey from the sun and just showering our planet every single second of every day. Now, this is where the real magic happens. So a photon zips down and smacks into a solar cell. All that energy has to go somewhere, so it knocks an electron loose. But here's the secret sauce, a special layer inside the cell called a PN junction. Think of it like a bouncer at a club with a strict one-way out policy. It grabs all those loose electrons and shoves them in the same direction. And that orderly, single-file line of electrons on the move? Yep, that's electricity.
All right, so we get the science on a microscopic level. Photon, electron, flow, got it. But how do we scale that up? How do you go from one little cell to a massive power plant that can light up a city?
Well, building a big solar plant isn't a one-size-fits-all kind of thing. It's more like you're ordering from a menu. Engineers have all these different types of solar panels to pick from. You know, you've got your standard, reliable mono PERC. But hey, if you're building in a super hot desert, you'll probably want HJT because it loves the heat. There are even these awesome bifacial panels that suck up energy from both sides. It's all about picking the perfect tech for the specific spot.
Okay, you know what? Let's play engineer for a second. Let's say we have a village and they need 1,000 kilowatt hours of energy every single day. How would we even begin to design a solar plant for them?
First things first, you got to figure out how powerful the plant needs to be. That's its capacity. So if we figure we get about 5 really good hours of strong sunlight a day, a little bit of math tells us we're going to need a 200 kilowatt plant to hit that 1,000 kilowatt hour target.
So what does the 200 kilowatt plant actually look like? I mean, is that big, small? Well, if we use pretty standard 550 watt panels, you're looking at 364 of them. So you can see how an abstract number starts to become a real physical field of glass and silicon, just soaking up the sun.
Okay, now let's get down to the questions that everybody really cares about. Is this stuff actually affordable? And is it really that much better for the planet? Time to break down the dollars and cents of it all. So this number right here, this is an absolute game changer. It's the levelized cost of energy, which is just a fancy way of saying the final price for every bit of electricity the plant will ever make. For solar, that number can drop as low as 2.5 rupees per kilowatt hour. I mean, that is ridiculously cheap. It's officially one of the cheapest ways to generate electricity on Earth, period.
And if you thought the cost was impressive, just check out the environmental side. It's even more dramatic. Over its entire life, from manufacturing to disposal, a solar plant is responsible for about 45 grams of CO2 for every unit of electricity. Now look at coal, 900. It's not even a contest. That's a drop of over 90% in carbon emissions. That is just massive.
But let's be real, nothing is perfect. The pros are huge, right? Once it's built, the fuel, sunlight, is free. The running costs are super low. But you gotta balance that with the downsides. The sun, you know, it goes down at night. Storing power in big batteries is still pretty expensive, and you need a good chunk of cash up front to build the thing in the first place.
And that whole day/night problem leads to one of the biggest challenges for the people managing our power grids. And I gotta say, it has the best name. You're gonna love this. They call it the duck curve.
So why a duck? Well, it's a simple timing problem. Solar panels are cranking out the most power in the middle of the afternoon. But when do we all get home and turn on our lights, our computers, our TVs? In the evening. So if you plot that on a graph, you see this big dip in demand from the grid during the day, followed by a super steep ramp up as the sun goes down. And that shape, it looks just like the back of a duck. Taming that duck is the next big puzzle to solve.
So where is this all going? What's next? Well, for a real peek into the future of solar, you have to look at India. It's quickly becoming a global solar superpower.
And when I say superpower, I'm not kidding. India's ambitions here are absolutely breathtaking. They're shooting for 500 gigawatts of renewable energy by 2030. That's a mind-boggling amount of power. They're already home to some of the largest solar parks on the entire planet. And for India, this is more than just clean energy. It's about energy independence and powering huge economic growth.
And the technology itself is not standing still. The next wave of solar tech sounds like something out of science fiction. We're talking about things like perovskite cells that are incredibly efficient, solar farms that float on water, something called agrivoltaics, where you literally farm crops underneath solar panels. And then there's the ultimate prize, using solar to create green hydrogen. Basically, figuring out how to bottle sunshine and use it as a clean fuel anytime, anywhere.
And that brings us right back to our big question, but maybe with a new twist. We started by asking if solar could power our world, but what if that was thinking too small? What if the true destiny of solar energy isn't just to make our electricity, but to become the source of our future fuel too?